So we are opening our notes to 5-3. We are now looking at solving. So the topic is now 5-3, solving by factoring. And I want you to try the 2 warm-up problems at the beginning of that page. Okay. So, in number 1, we have 4 taken out, leaving you with x squared plus 5x minus 3. And then in number 2, somebody suggested in years past to simply take out a 3. However, when looking at it, they had to recognize that there is also a 3x. So you had 3x taken out, leaving 3x minus 7. So back in the day when my Promethean board functioned, I used to have kids come up and write them. So, like I said, today we are looking at quadratic equations and we are going to be solving. We are now solving quadratic equations using our technique of factoring that we've been focusing on for the past few days. In order to solve something, we're going to apply the zero product property. The zero product property states that if a product of real numbers is 0, then at least one of the factors is also 0. So the zero product property states that if a product of real number is zeros, then at least one of the factors is 0. So for example, if A times B equals 0, then A has to be 0, B has to be 0, or both A and B are both 0. So that is the zero product property. You're going to hear me reference it as we are solving. So in this first example, the equation is Yep. So in that first example, the equation is already factored for you and set equal to 0. So this is like where we came from. This is where we're going. So what do? What we do is say, okay, this is kind of like A. This is kind of like B. So I'm going to set A and B both equal to 0. And solve both separate from the other. So here you subtract 4. Here I subtract 7. Over here I have to also divide by 2. So my two solutions are -2 or -7. My two solutions are -2 or -7. So the steps with which we're going to do this are almost identical, but now we add this step 1, which is to make sure the equation is equal to 0. So all solving by factoring equations have to be equal to 0. All solving by factoring equations have to be equal to 0. Then we do what we've been doing, which is to factor. So these are all the techniques we just finished studying up and reviewing. Now we take those two factors and set them equal to 0 using the zero product property, and then we solve. So for the first example, I'm going to actually walk through each of these steps doing a problem. So here's problem number 1. Step 1, set equal to 0. So currently this problem is equal to 10. So to set it equal to 0, we have to subtract 10 from both sides. So step 1 for solving by factoring is set equal to 0. So we do that in this problem by subtracting 10. Step 2 is to factor the equation. So we're going to set up our magic x by taking the 3 times -10 to get -30. We need two factors of -30 that sum to -1. So those two factors are -6 and 5. They're going to replace my middle terms. So then we set it up and do factor by grouping and take out our GCF of each factored part. After we've taken out that GCF, then we set it up as a two binomials set equal to 0. And now is the new part where we set each factor equal to 0 using the zero product property. So that means that 3x plus 5 and x minus 2 are both equal to 0 now. And my solutions are x equals -5/3 or x equals 2. questions, comments, concerns, everything pretty good? All we're doing is adding that little extra part at the beginning and the little extra part at the end. So in this example, once again, we need to set the equation equal to 0. So I'm going to move this 6x to the opposite side. Our equations need to be in standard form, meaning it goes x squared, then x, then the constant. We're going to factor it, so two numbers that multiply to negative 27 and add to negative 6. So that's a negative 9 and a positive 3. When you set up your factor by grouping, you always put the negative first. Take out an x, leaving x minus 9. Take out a 3, leaving x minus 9. So in factored form, you have x plus 3, x minus 9. Applying the zero product property, we say x plus 3 equals 0, x minus 9 equals 0. Therefore, x equals negative 3. Sorry, tried to move it up, it didn't work. And x equals 9. In the next example, we need to rewrite it. This time we notice the leading coefficient is not 1. So I'm going to add over my 5x. So I have 2x cubed, or sorry, 2x squared plus 5x minus 3 equals 0. Setting up my magic x, 2 times negative 3 is negative 6. So two numbers that multiply to negative 6 but add to 5. So that's one positive and one negative. So that'll be a negative 1 and a positive 6. Writing the negative 1 first makes factor by grouping just easier. So we take out an x, leaving 2x minus 1. Take out a 3, leaving 2x minus 1. So factored form is 2x minus 1, x plus 3. But now this is equal to 0, and what you'll notice is I write equal to 0 on every line. You must also write equal to 0 on every line. Not writing that is not equivalent. That equal to 0 is part of this problem. Then you set each factored form equal to 0 individually. Solve for x. So we add 1 and then divide by 2. So you get x equals 1/2. And then over here you subtract 3. So you get x equals negative 3. So you get x equals 1/2 and x equals negative 3. In the next example, this technique is a little different. So I told you at the beginning of class today, the very first thing we want to look for anytime we are factoring a problem is a GCF. So in this example here, I noticed that there is a GCF of each term, and that is 2x. Starting by taking out the GCF gives me 2x factored out, leaving x plus 4. So in this case, I don't get a product of two binomials. I get a monomial times a binomial. Zero product property still applies. I have 2x, x plus 4, x equals 0, and x equals negative 4. So this is still a quadratic. It's just that this quadratic now has a point that goes through the origin. Therefore, your y-intercept and x-intercept are 0, 0. And that leads us to a factored GCF. So, your homework is the next page in that packet. So your homework is the next pages in that packet. You are doing the front and the back of the 5-3 solving quadratic equations by factoring homework. So doing the front and the back.